Boys and girls, we are talking 3-5 for our lesson today. We're talking about arithmetic sequences. An important question up here for our essential question. And please make sure you have a sequence written down because we will be using that word, and an arithmetic sequence. And so a sequence is just a specific set of numbers in a specific order. And a arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. Now the common difference is also known as the letter D. Now the words increase or decrease tell us that we have to be adding or subtracting. So an arithmetic sequence is either adding or subtracting by that same constant rate or the common difference. So that's important for us to have written down. Now here's an example, or two examples. From here to here it goes up by 2, up by 2, up by 2, up by 2. So my common difference is then 2. This one's going down by 2, 4. Oopsies. Down by 4, down by 4, down by 4. So D in this case is a negative 4. So it's important that we have that stuff in our brains. All right, let's keep it trucking. We're going to move on to the next thing. So for us to determine if a sequence is arithmetic or not, we have to just have that common difference. So all we're going to do is we're going to check. Is the change from the first number to the second number the same as the second to the third? Is the same as the third to the fourth? So negative 15 to a negative 13 is a plus 2, plus 2, plus 2. So yes, these are arithmetic because it has a common difference of 2. Now the fraction one below, 7/8 to 5/8, is subtracting 2/8. From 5/8 to 1/8, it's subtracting 4/8. From 1/8 to a negative 5/8, it's subtracting 6/8. So although there is a pattern, they are not adding or subtracting by the exact same thing every single time. Therefore, this is not an arithmetic sequence. Moving on. Now this is the part where I think some kids get confused because we use all these different words. In order for us to create a rule or a function to find the nth term of an arithmetic sequence, we will be using this formula. A sub n is equal to a sub 1 plus n minus 1 times d. Now we already said that d is the common difference. A sub 1 is the first term. So this is the first term, and then a sub n is just saying if I'm looking for any number, so whatever n might be. And so we all know what all these things mean now. So here's an example. Our job is to write an equation for the nth term. We know that we are using the equation where a sub n is equal to a sub 1 plus an n minus 1 times d. So we can use some things that we know. A sub 1 is just the first term. So to have a sub n equal the first term of 1 plus, now n minus 1, that stuff never changes, but we do need to figure out what d is. And d is figured out by what is the common difference. Now that should be something quick and easy to find, that the common difference is 9. So when we solve this or create a function rule, we're going to now use our simplifying process, which means we have to distribute the 9 to everything inside the parentheses. That gets us a 1 plus 9n minus 9. And just like we did before, we're going to combine our like terms, which is our 1 and our minus 9. So that means that our a sub n, or our rule, is 9n minus 8. Now this is the rule, the function rule, and for us to find the 12th term, all we have to do is plug in the number 12 for n. So n is the number of term. So now we do the 12th term. So we do 9 times 12 minus 8. Now 9 times 12, I believe, is 108 minus 8. So the 12th term would be 100. So a sub 12, or the 12th term, is 100. Now let's say you didn't know how to do this. You could take that long, horribly long process. This is the first term, this is the second term, the third term, the fourth term, and do that all the way until you get to the 12th one to figure out that n is 100. Or you could use some skills in math and just plug them into the formula. So that's a little trick for us. Helps us make math a tool to make things easier. So similar type of a problem. A arithmetic sequence 12, 23, 34, 45. It represents the total number of ounces that a bag weighs after each additional newspaper is added. So we're going to write a function. That means we have to use our formula. A sub n is equal to a sub 1 plus an n minus 1 times d. Now we know that the first term was 12, so we're going to plug that in. We know that the other things stay the way they were except for d, and d is going to be figured by our common difference. Now it looks like we're adding 11 every single time, so we're going to multiply by 11. And of course, to simplify, just like we did before, we are going to distribute that 11. So we have 12 plus 11n minus 11. Now we combine our like terms, 12 and a negative 11, to make our official formula. So the official formula will be a sub n is equal to, let me get rid of that line, I didn't mean to put it there, is equal to an 11n plus 1, because 12 and a negative 11 make a plus 1. Now if we were to graph this information, we had the numbers of 12, 23, 34, 45. Now what this is telling us is that we have our first term, our second term, our third term, and our fourth term. Now the number that is based off of the term is going to be our y values. The number that our term is our x values. So this is my domain, because remember that x is the domains. This is my range, the y values, and I would be able to easily graph these because I am making ordered pairs. 1, 12. So that's an ordered pair that I can graph. 2, 23. Ordered pair that I can graph. Now your graph is going to look, just a quick sketch, it's going to look like it's going upward like this. So it's important that we understand that information. My sketch is pretty horrible, but I wanted you guys just to have a quick idea of what your graph is going to look like. Your assignment is on the screen in front of you. We'll be doing this in class. If you need any help, make sure you ask for it, because we want to make sure you understand this information. Thanks, guys.